So this is a bit of a different talk now. So I'm Andreas Monitzer. I'm doing like paid Rust mostly, sometimes other languages, but um, I have a education in game development, which I never used at a company, not really. So, but I learned a lot of things about software architecture for games, and I don't think that the difference between a game and a regular application is that large. So this is a talk about basically an introduction to a concept from game development that I think could be used in other languages and other applications as well, because it's just a tool for managing data, which is something everybody does in some way. So the thing is called Entity Component System, ECS, which is a nice name for it because it consists of entities, components, and systems. So it's easy to remember. And there are a few implementations for Rust for this. I'm going to present one specifically, the Bevy implementation. So Bevy is like an open source game engine for Rust. There are a lot of smaller game engines, but Bevy is currently the largest one. Mostly because all of the other large ones have died off because they all switched to Bevy. So the basic idea behind Bevy is that everything is in this entity component system, and everything you want to do, you have to do through this system because it's all about managing data. There are other game engines like Unity, for example, that say they have the rendering tree, like there's a room and inside the room is this and that and that. And then you render just this room, but in Bevy has the different direction. It says that it doesn't matter what you display on screen, everything is data and everything is connected to everything else in some way. So first off, this is a programming presentation, meaning that there are no slides. It's just Visual Studio Code in this case. First off, this is just an empty project, basically. The only thing I added was Bevy-ECS. That's the entity component system of Bevy. So Bevy is it's a collection of components. It has the basic Bevy crate just references all of the other smaller crates. It's all in one Git repository. And you can use every part of it separately. So you don't have to use like the renderer if you want to use the ECS. You don't have to use an input system. You don't have to use sound and so on. You can just say, I just want this one part. And in this case, it's the ECS. Although I don't think that anything else works without the ECS because they all hook into this system, because it's the core of Bevy. Which also means if you know how to use the ECS, you know how to use Bevy in some ways, because there's like different types and stuff, but it's easy to get started. So first off, how do we start? So usually the traditional way of programming games, in this case I'm using games as an example, but you can map it to whatever else you want. Like you have a game entity is a player, is an enemy, is a static object, is something else. This is the traditional object-oriented way of thinking about things. Like you have specialized entities that are derived from other entities. This works okay in programming languages like C# and C++. Doesn't work at all in Rust because there's no object inheritance. That just doesn't exist. So when people looked into programming games with Rust, because Rust is like the super new language with great performance, so you should be able to program games in this. The problem was you can't use all of these structures because you can have like fake inheritance using the sref trait, but that doesn't really work over a longer time. Like you will never get to a large project with this. But there's a different concept, the ECS, which means that a game object, which is like a generic object, that's something in your application, doesn't have anything on it. It's just an empty object. And then you can attach components to it. So the entity is empty. You attach components to it, and the definition of what this entity can do and what data it has is a collection of all these components. So everything you add to the engine is just components, and they attach together to entities, but the entities themselves don't have anything on them. So no data. The only functions it has is for lookups. So like looking up a specific component that's attached to it and stuff like that. So to contain all of these entities, you need a world first. So let's create this world, which has to be mutable, because we're going to add stuff to it. Like the position in space could be one component, or your current health, or the health of this one entity would be one, or the currently playing audio on this, or the capability to play audio could also be a component, for example. So now we have a world, and we can add an entity to this, which is world.insert. Spawn. Insert is something else. Spawn empty is the great example. So that's an empty entity which doesn't do anything, but you get a reference back. So we have an entity mute here. So mute because you can add stuff to it, which you probably want because an empty entity is not that useful. So let's add some example here for how do I create a component. Let's start with the name component, which is just the name of this entity. And I can also attach components while I'm spawning the entity, which is just I think missing some brackets. No. Yeah. So to specify the components, you have to create a tuple, because this is a bundle. Let's do this in multiple lines. Right. Yes, this is not a component yet, because I have to derive the component, and I will also probably derive. Yes, I need to import this component, the ECS. Okay. So if I want to attach multiple components to this entity, I can just add more to this tuple. So this spawn function is implemented for tuples of up to 8 components, I think. And now I have an entity here that contains a name, doesn't contain anything else. Let's also add position. Like this, and we have to derive autocomplete. Yeah, we can also derive the park. Always derive the park. And yeah, position. Oops. So it's all just regular Rust. Yep. So now we have an entity with 2 components attached to it. And the question now is, what do I do with that stuff? So I can also attach and remove components from an entity at runtime later on, but it's not really important right now. So the big thing that Bevy does is that it adds an engine for managing manipulating these components in a multi-threaded way. Not necessarily, but it also supports it in multi-threaded way. So this looks like this. First off, you have to define a function like that takes a query, which I also have to import. Let's start with position. And we have derived debug, so we can use this. Okay, so this is just a regular function, but it takes a query parameter. And this is a for the Rust compiler, it's nothing special. For us, it's special because it you can specify multiple things here, and it has to be in a tuple like this. So, and now I can say I want to let this function run with this query whenever the world is processed. So that's a schedule. Usually in a game, this would be integrated with like the windowing, so W init. You create a window. You have a an event handler in there, and it manages everything. But since we're in a command line, it you have to do that yourself. But as you can see, it's not complicated. So now I'm adding a system, which is called list entities. And then I'm going to tell it to run this once on my world. So I can have multiple worlds here as well. So maybe show this. So this is the code. Yeah, there are a lot of dependencies in Bevy, of course.
It's kind of super annoying that Rust has to compile again because it compiled already initials to your code, right?
Yes, but it's a different target. That was the check target. This is the debug target. So, as you can see here at the bottom, I get I get one query result here, of course, because there's only one entity and it has a position. And now I can extract this position out of my entity. And let's better demonstrate this. Let's we don't need to store the entity reference here actually. That's good enough. Now we can add another one that, let's say, only has a name, has no. Let me reformat that. It's kind of annoying. So like this. Yep. So now I have another entity here that has a name but doesn't have a position. I'm not. The query doesn't contain a name, so I can add the name here, like this, and now I get a tuple here in the iterator for also the name. now I can say entity name at position. Now if I run it, I get still only this one because the other one doesn't have a position. So you're doing a query over your world where you say, give me all entities that have a position and a name. And so it's like a database in memory, which is the concept where this came from in the first place. So yeah, so now I have a name here. Maybe this should be like name.name, which doesn't really matter. Like this. Now I can also, let's add another one, which just has a position. And no name, just to demonstrate. So now this one is not part of the query. Even if you wouldn't access the name in your loop, it still wouldn't be part of this query. So only the one that has both is shown here. And you can add any number of systems here. So these short functions are called systems. That's the S of ECS. And you can add any of them. But there's also another situation where you can say, I only want to have parts of these entities, not all of them. For example, if you have enemies and friendly players, and you don't want to have your enemies, even though the enemies have the same components attached to them. So what you can do is you have an empty component, and you're attaching it to, let's say, this one. And now I can say, let's also give this a name and give this a position. So now all three are the same, but one of them also has the player component. And I don't need it to be part of this thing here, because I don't actually need the data stored inside this player because there's no data. So that's why I can say with player like this. Then it's of course I have to so quick fix import. Yeah. Now I can just tell it to ignore the rest. So what happens here is that the data is not extracted in the query, which is better for data locality. So you aren't fetching data that you aren't actually using. And now only one line should be output here still, even though there are three entities with the same components I'm reading. And what I also can do is without here. So it's the same idea, but it's a negative query. Now the other two are shown here. I should have called them differently. 1, 2, 3. So 1 and 3, because on 2 there's a player. We only want entities that don't have a player. And all of this is done via the type system of Rust. I tried to look into how they're doing this. I don't know. The only thing I know is that they're also doing. Okay, let me step back one. You can also do this. You can say that it should be mutable here, which means that you can do stuff like. Is that possible? Right. This also has to be mutable then. Mutable name like this. query has to be mutable now. Yeah. Now I'm going to run it twice so you can see the difference. Now stuff is attached at the end. So you can mutate them in there as well. Now the crazy thing about all of this is that this is multi-threaded. So if you have multiple systems, it's possible that they're running at the same time. But Rust stipulates that you can't have multiple mutable access to the same thing from multiple threads at the same time. And what this system does is that it checks for this query which entities would match this query. It collects them, looks is there no overlap between two systems, and if yes, they can be run in parallel. Even if the same component is used in multiple entities that have that are part of one query and another, but not both at the same time, it can still separate them and run them in parallel using regular async and stuff like that. And that's the, yeah.
If there's an overlap, it just forces it to be on the same thread?
Not on the same thread, but on the not at the same time. So it has some unsafe stuff in there because it has to force it. It has to tell the compiler that it's fine that this thing is mutable and accessed from this thread, because it guarantees internally with its own systems that they are separate, that they not have the same reference to the same thing. Yeah.
Is there any kind of reference counting behind it in the library?
As far as I know, no. But I haven't checked the source code of everything, so this is pretty complex things that are happening inside there. Yeah. Also, one thing, if it's not mutable, for example, if I have two entities with position, no, if I have one entity with a position that is used from two systems, then it doesn't matter because you can have immutable access at the same time in multiple threads if it's sync.
What if you want to do parallel stuff in your game? Let's say the two runs that you're currently having, could you parallelize those?
No, because, well, you can have two worlds that are separate from each other with their own entities that can run in parallel.
So the compiler would detect that because both try to modify the name, so
Well,
it wouldn't run in parallel.
yeah, if you run it in one run. So you see here there's mutable, it gets a mutable reference, so the compiler stops you from using the same world there. It can run in the same schedule. Schedule is like the runtime that manages the when things are executed. And with this, the compiler stops you for doing stupid things. Hold on. So, okay. Yeah, and I think this concept of running things in parallel automatically behind the scenes could be used in other applications, like, for example, simulations and AI stuff and everything where you have to do lots of processing at the same time. And you don't want to mess with parallelizing yourself. You just define what the things are, and which systems can be run in parallel is then determined by the Bevy-ECS and not you manually. Also, you can change things at runtime, and it will still manage all of this behind the scenes. And it does a lot of interesting things, like you would expect that the query thing is a macro, but it's not. The query is just this tuple. There's a lot of impulse of query with a tuple with one entry, two entries, three entries, and so on, up to 8. And that's how this is done, and without is just a special type that handles all of this. And with is the same. Yep.
You just said there's tuple, the query can have up to 8
Yeah.
components inside. So what if you need to have a system that depends on more data?
I think it's simply not possible right now. Although I think you can add a tuple at the end and then nest those tuples. I think that's also implemented, but I'm not really sure. Yeah, so another thing that's not really part of ECS, but also necessary in practice is it's called resources, which means what if I want to have some state here? Like this thing is a function that has no state that can be passed into it, so that's of limited usefulness. So and that's why Bevy added resources. For example, yeah, let's declare the resource first. It's also a derive. Like something. Yeah, as always, you have to import. Now I can add this resource here. That's that was the insert resource. Uh, and now I can tell the system that I also need this resource, which is like there's a rest type for this. Typo. I can actually just use it here. And fix the types. And this resource, there's also resource mut for mutable. And this way you can change data here and pass it in, get it back, exchange data between systems. All is here, and also the same things apply here. So if you have mutable access to it, nothing else that also needs mutable access will run at the same time. If it's just like this, immutable, then it can run at the same time. And there's also message passing, works nearly the same as resources. So you can have you can add like events to an event queue, and some other event receiver can then manage those events or process those events. And the scheduler will also take care that the receiver of events will be run after the sender of events. In general, the order of how the systems are run is undefined, depends on what entities are there and so on. But you can also define barriers where you can say this system has to run after this system, or there's a global barrier. You can say this system is run before this barrier or after this barrier. So you can have defined defined behavior in time. But you have to be careful because every time you do that, the parallelization goes down, of course, because those barriers are a point of single where everything runs single threaded, and then it can branch off again. Okay, yeah, that's basically it. It's just something to think about. Maybe you have a project where this would fit, and I think it's very powerful. And as I said, Bevy does everything through this system. So if you want to draw something on screen, you have to add it as an entity to the world, then attach a rendering component to this entity, then maybe attach a texture to this entity and so on, and all of this combines together to render something on screen. There's also like a position like I showed. Okay, any questions? Yeah.
How heavyweight is such an entity? So in terms maybe of byte or probably it has an MPST channel or something like that? Or?
An entity by itself just a pointer to nothing, so it's very lightweight. I think it has like 8 bytes or something like that. Of course, every time you attach a component, it gets larger, but it's just like a list. No, components are stored in their own table. They have a reference to the entity ID. So the entity itself stays small, but there are 2 types of components. Well, memory management for components, there are 2 types supported. So there's like a table, which is a linear list of components that exist in this world. And every time it removes one, it shrinks the list. And there's a sparse table where I don't know exactly how it works, but there's some other downsides and upsides. So you can select which one you want in this derived component thing here to save memory for your specific use case. Because Bevy can't know what you want to do with this at compile time.
So like the currency is managed by an entity, it's like from the system itself.
Yes. But the entity itself is very small.
How heavy is so I suppose it uses a sophisticated runtime
Mm-hmm.
at runtime that manages everything. How heavy is that runtime? How much overhead?
The problem with the question is compared to what? Because you always have some kind of losses when you do a runtime like that, like parallelization. It's of course more than a regular parallel 4 spawner. But it has probably less overhead than if you implement everything manually. It's hard to compare, but of course there's an overhead to all of this, especially since the scheduling of all of this is single-threaded. So that there's a point during when I call run, the first thing it does is single-threaded, and then it can spawn into multiple threads or schedule multiple tasks on the worker threads, of course. So that's also the problem that you have to be careful what you do at this management period, because that's the expensive part, Amdahl's law and stuff like that.
Is there a single-threaded version of it?
What?
Is there a single-threaded version of it? So that doesn't use multiple threads and doesn't need to like synchronize?
Yes. So Bevy also runs on WebAssembly on the web and doesn't use threads there because there are no threads. It would be possible to do threads on WebAssembly, but they are not doing the trick because that requires Rust nightly. I'm doing that in my own project, and it's a big headache because you need special HTTP headers on your things, and you need Rust nightly, and you need special compiler flags for this. Then it works fine, but Bevy isn't doing that right now. But that would be a talk in itself. So Bevy can run single-threaded. I don't know if how you can trigger that here, but probably on the schedule you just have to tell it that it should be run single-threaded. Yeah.
Can you dynamically add components to entities?
Yes.
From the system itself?
From the system itself, I don't think so.
Where would you do it?
I could do it here. Yeah, there's also another thing I skipped, which is there is like a commands list where you can add stuff. There you can add components. So commands list is like a queue of things that Bevy should do. So you can have your own event queues, but Bevy has its own commands list. And there you can say spawn a new entity, for example, add a component to an entity, and it doesn't execute that right away, but the system can schedule that, and after everything else is done, it runs this queue and executes all of the commands there.
Do I understand correctly that it's a way to handle events?
Yes. Other questions? Okay, yeah, thank you.